hydroelectrical power plant and how it will be works, okay, and what are the advantages and what are the disadvantages of a hydroelectric power plant. Hydro, okay, the name itself indicates, okay, hydro is nothing but water. Here from water you are getting the electrical energy. Okay, so now in this hydro, so hydro means this is which energy sources? This is a renewable energy sources. That means it occurs naturally in the nature. Okay, so here from the water, how to get the electricity? We are seeing in the hydroelectric power plant. So in hydroelectric power plant, okay, so see, working principle. First of all, you can see hydro means water. So where you can construct the hydroelectrical power plant means wherever you have a lot of water resources at that place, first you can choose that place and you can construct a hydroelectrical power plant. So water means water is a not constant, it will be flowing. Okay, so to generate the electrical energy, first of all you should store that water. That's why here you can first of all you can construct the dam. Okay, so to construct the hydroelectrical power plant, first of all you construct a one dam. Okay, so that is necessary. First you can see the working principle of a hydroelectrical power plant. Hydroelectrical power plant is nothing but, okay, the the water will be converted into the steam. Again, that steam energy will be converted into the electrical energy. So first of all, either that is any power station. So first of all, that so from that source you can convert that into the steam energy. So already I will explain in the thermal power station. Okay, that will be converted into the steam energy. From that steam you can get converted into the electrical energy. Okay, so see here first you can see the working principle. Potential energy is the energy which a substance has due to its position or state. That means water having always potential energy. The water behind a dam has potential energy because of its position. Okay, the water can fall from his position and exert a force over a distance and therefore do work. In hydroelectrical power plant, the force is used to drive the turbine. That means here in hydroelectrical power plant, the water force is used to drive the turbine. Okay, whenever you can force a water through the turbine, at the time the turbine blades will be rotated. Okay, that rotating energy will be converted into the mechanical energy. At that time, that mechanical, see here in the principle of hydroelectric, see, I will say that first of all you can store the water, you can construct a dam. Okay, from the dam here you can give the water directly to the turbines. Okay, so these turbines for this turbine here you have connect a generator shaft. Okay, the shaft is nothing but the one of the part of the generator. Okay, here the turbine will be connected through a generator shaft. Okay, whenever from the dam the water will flow through the turbine, so whenever the water will be forcefully, so here you cannot use small amount of water, you can use a large amount of water at a time. Whenever heavy water will flow through the blades of the turbine, when that force will be forced on the turbine blades, at that time the turbine blades will be rotated. At the time they can produce a mechanical energy. So through that shaft it is connected to the generator. Okay, at that time this generator will be converts the mechanical energy into the electrical energy. That is the working principle. So here see, water out means whenever the blades of the turbine will be rotated, so there will be a total amount of water will be not converted into mechanical energy. Some amount may be wasted. Okay, that will be here from this place the water will be coming out. Okay, see, this is the inside of a hydropower plant. First of all, reservoir. On the reservoir you can construct a dam. Okay, from the dam the water will flow through the here. See here inside this is a turbine. Okay, whenever the water will flow through the turbine, at the time the turbine blades will be rotated. So this is a turbine, entire inside a turbine. Whenever the water will flow through this turbine blades, at that time the turbine will be rotated. For this turbine through a shaft generator, here generator will be connected. So this generator will be converted into the electrical energy. Okay, from that electrical energy through transformer you can supply the power to the powerhouse. From this by using the power lines, that means transmission lines, the power will be transmitted. See here, some amount of water will be coming out in this way. That means whenever the turbine blades will be rotated, the entire power will not be converted into the electrical and that means mechanical energy. See here also, this is also another diagram. Okay, this is reservoir, dam, floodgate. Okay, floodgate means already you know, whenever there will be floods will be released at the, that means floods will be occurs. Okay, so at that time there will be a large amount of water will be stored in the reservoir. At that time you can open the floodgates. Okay, a generator, this is a powerhouse, long distance power lines. Okay, so this is a turbine and this is a penstock. Okay, so penstock is nothing but it is a supply the water from the dam to the turbine. Okay, from the dam to turbine you can pass the water to the turbine. You can place a one tube, like a one tube arrangement, that is nothing but a penstock. See, this is the general layout of a hydroelectric power plant. First of all, reservoir. Head means, that means water, the water level. Here you can say is that the head water level. So on the reservoir you can construct a dam. Through dam, here you can place a this stored penstock. See, this is on the, this is penstock. On this penstock, here you can place a surge tank, pressure tunnel, gate, water flow. Okay, so here see, from this penstock, whenever you can open the gate, pressure tunnel means that means with pressure the water will first come into the surge tank. What is the meaning of surge tank means? Here whenever there will be a, in surge tank always you have placed a some amount of water. That means whenever there will be a scarcity of water, that means in summer seasons at that time there will be no availability of the water. At that time you can store the some water in the surge tank. At that time you can, from the surge tank you can place the you can supply the water to the turbine. But whenever there will be water will be available, at the time there is a no need of surge tank, directly from the penstock. So that means here inside another construction is there. That means separately for surge tank another route, for separately directly to the penstock there will be another route. So whenever you will be gate will be opened through this pressure tunnel, so the water will be coming to the penstock. Here inlet valve, whenever this inlet valve will be open through penstock directly the water will be coming to the hydraulic turbine. Whenever the water will be force the hydraulic turbine, at that time the turbine blades will be rotated. Okay, so at that time here see, the generator will be connected to the turbine. Whenever the turbine blades will be rotated, it will be converted into the mechanical energy. That mechanical energy is given to the electrical generator. The generator will be converts the mechanical energy into the electrical energy. Control room, transformer, these all total related to the power supply. That means the power transmission. Finally here at the generator you can get the electrical energy. Already I will say that. So whenever the turbine blades will be rotated, so at the time the entire water which is coming from the penstock will be not converted into the mechanical energy. Whenever the turbine blades will be rotated, at that time some amount of water may be wasted. Okay, that water with draft tube. This is a one tube. Through the draft tube, the water will be placed here. Okay, this is nothing but the tail water. You can assume here it is says that the tail water level. Okay, this is the layout. Okay, please share this PPT and practice this hydroelectrical power plant layout. So the layout is must and should. Okay, so either that is either thermal power station or nuclear power station or hydroelectrical power station, must and should you can practice the layouts. Okay, this is the layout and working of a hydroelectrical power plant. Okay, see. I will explain each and every part. So first must and should you want water reservoir and dam. So first here reservoir. In a reservoir the water collected from the catchment area is stored behind a dam. So wherever the water the total water will be collected in a one place, that is nothing but a reservoir. Behind that reservoir you can construct a dam. Okay. Dam, the purpose of the dam is catchment area. So this is the catchment area, this is the dam. Okay, so dam, the purpose of the dam is store the water and to regulate outgoing to flow of water. So that means dam purpose is nothing but to store the water and regulate the outgoing flow of water. That means whenever you want the water, at that time the water will flows from the dam. Okay, the dam helps to store all the incoming water. It also helps to increase the head of the water. Okay, so the dam to helps the store the, so whenever if suppose you will not construct the dam, at the time the water will be not stored. That means the water will be flows, okay, another places. Okay, that's why you must and should construct a dam. Okay, here the dam helps to store all the incoming water. It also helps to increase the head of the water. So okay, here head means the water level. Okay, in order to generate a required quantity of the power, if that means whenever you can store the proper water, at that time only you can generate a proper electrical energy. Okay, spillway, spillway is nothing but this total is nothing but the spillway. Okay, so spillway, excessive accumulation of water endangers the stability of the dam construction. Also, in order to avoid the overflow of our the dam, especially are provided. Okay, this prevents the rise of water level in the spillways is nothing but that means whenever the water flow is heavy, okay, at that during rainy seasons, spillways is nothing but, already I will say, so floodgates. Okay, spillways are nothing but the floodgates. Okay, whenever in rainy seasons there will be very lot of floods will be occur. At that time the water will be a lot amount of water will be stored in the dam at that time. So the water flow will be increases at that time. By using this spillways, you can you can avoid the some amount of water. Spillways are passages which allows the excess water to flow a storage area away from the dam. See, so from the dam these spillways are away the water level. Gate, here already as I will says, gate is used to regulate or control the flow of water from the dam. Through gate, okay, you can regulate or control the water level. Pressure tunnel, here I will say that pressure tunnel, it is a passage that carries water from the reservoir to surge tank. Okay, from the reservoir to surge tank, the pressure tunnel will be supplies the water to the surge tank. Surge tank, okay, a surge tank is a small reservoir or tank in the pressure. Okay, see, directly water level for due to sudden changes in the or falls. The purpose of surge tank to serve as a supply tank to the turbine when the water in the pipe is accelerated during increased load conditions, as a storage tank when the water is during reduced load conditions. That means, see, whenever high pressure water will be coming from the pressure tunnel to the surge tank, at that time the water will be conditioned. Okay, according to the our pressure level, the water will be conditioned in the surge tank, and then the water will be supplied to the turbine, as well as to reduce the distance between the free water surface in the dam and the turbine, thereby reducing the water hammer effect on the penstock, and also protect the upstream tunnel from the high stress. See, here whenever the water will be coming from the reservoir, so the water will be coming from the reservoir is very high quantity. At that time, very high quantity water, if suppose there will be not present such tank, at that time the large amount of water will be directly coming from the penstock to the turbine. At that time, whenever the large pressure water will be goes to the penstock, at that time the pressure will be damaged. That is nothing but the water hammer effect. Okay, to reduce that water hammer effect also, see here the water hammer effect, the water hammer sorry, the water hammer effect defined as the change in the pressure rapidly above or below the normal pressure. Okay, so that means that is the water hammer effect is defined as the change in the pressure above or below. That means so the water always maintain some particular normal pressure. So water hammer effect means either the pressure will be increases above the normal pressure level or below the normal pressure level, there will be sudden changes will be occurs in the water flow. That is nothing but the water hammer effect. Due to that water hammer effect, that penstock will be maybe damaged. That's why the water pressure will be set right in the surge tank. That is the purpose of the surge tank. Surge tank is also very, very important for 5 marks. Okay, so sometimes maybe ask what is the surge tank, what is the purpose of the surge tank. At that time here you can write this. Next one is penstock. Penstock is a closed pipe or steel of concrete for supplying water under pressure to the turbine. Okay, so what is the purpose of penstock here? Penstock is a closed pipe or so that means it is manufacturing with either steel or concrete, okay, for supplying water under pressure to the turbine. Okay, so that is nothing but the penstock. This is inlet valve. Water from the penstock flows to the turbine through the inlet valve. Okay, the valve may be partially closed or open, thereby regulating the pressure of the water flowing to the turbine. That means whenever this turbine will whenever this inlet valve will be open, at that time from the turbine to the at that time from the penstock to the turbine, the water will be supplied. Okay. Turbine, hydraulic turbine. Turbine is also called a prime mover. Okay, so the hydraulic turbine converts the energy to the mechanical energy. This will flows through the turbine. That time the turbine blade mechanical energy. The mechanical energy available on the turbine is coupled to the so see here the mechanical energy, the rotation energy to the shaft on electrical generator. So that means directly here you can connect the electrical generator, okay, and electricity is produced. The water after performing the work on turbine blades is discharged through the draft tube. Okay, so the prime movers which are common use are Pelton wheel and Francis turbine and Kaplan. See, so turbines are so many types. Okay, but mainly in hydroelectrical power plant we are using our Pelton wheel. Pelton wheel is nothing but that is one turbine, Francis turbine and Kaplan, Francis turbine and Kaplan turbine. Okay, so see. Draft tube, it is connected to the outlet of the turbine. Okay, this is it allows the turbine to be placed above the tail water level. Okay, so tail was okay, so this is placed above the tail water level. Okay, they are tail raise. Tail water level is the water level after the discharge from the turbine. The discharged water is sent to the river. Thus the level of the so here you can place a from the turbine, whenever the turbine will be rotated, at that time so this is total enter placed in the water. Okay, so whenever the turbine blades will be rotated, at that time the some amount of water may be wasted. Okay, the total water will be collected as a tail water level. Okay. Next one is electric generator step up. So this is electrical generator and this one is step up transformer. Okay, as the water rushes through the turbine, it spins the turbine shaft which is coupled to the electrical generator. The generator has a rotating electromagnet called rotor and a stationary part called stator. The rotor creates a magnetic field. See, generator. So here you can use the alternator. Alternator is nothing but AC generator is called as alternator. Okay, alternator mainly having the two parts. One is stator, another one is rotor. Okay, see, the generator has a rotating electromagnet called a rotor and a stationary part called a stator. Okay, the rotor creates a magnetic field that causes a electric charge in the stator. Okay, so that means the stator is a stationary part. Whenever the rotor will be rotated at that time it will produce electricity. The charge is transmitted as electricity. At that time that charge is nothing but the electricity. The step up transformer increases the voltage of the current coming from the stator. See here generator, from the generator the electricity will be coming. Here you can use this transformers are two type, step up transformer and step down transformer. The step up transformer is nothing but it step ups the voltage. Okay, and the purpose of the step down transformer is step down. That means step up means it increases the voltage levels, step down means it decreases the voltage level. Whatever the voltage coming from the generator is some amount small, Okay, that voltage will be a step up by using here step up transformer and get distributed through the transmission lines. Okay, see that a total is layout, okay, and working principle as well as the different parts in the hydroelectrical power plant. Okay, so next you can see the classification of hydroelectrical power plants. Okay, hydroelectrical power plants are usually classified according to the availability of head of water. What is the head? The height of water is nothing but the head. Okay, the height of the water in the reservoir is nothing but the head. Okay, here according to the head of the water, the hydroelectrical power plants are mainly classified into three types. Those are high head power plants, medium head power plants, and low head power plants. High head power plants. High head power plants is nothing but head of the water is more than 500 meters. Okay, so whenever whenever the head of the water is more than 500 meters, those power plants are called high head power plants. Okay, the turbines used in such plants is nothing but Pelton wheel. I will say that there are different turbines: Pelton wheel, Francis turbine, Kaplan turbine, either impulse turbine, like this. So many turbines. Okay, the turbines is nothing but this is one is a mechanical concept. Okay, so the this entire full description about turbines is coming in a mechanical engineering. Okay, so here you know just what are the turbines and okay what are the turbines. Okay, so in high head power plants we are using the turbine is Pelton wheel. Okay, medium head power plants. Medium head power plants is nothing but head of the water ranges from 80 to 500 meters. Okay, whenever the head of the water in between the 80 meters to the 500 meters, at that time the turbine used in such plants is nothing but the Francis turbine. Oh, and the turbine used in medium head Francis turbine. Low head power plants, whenever the head of the water ranges from 1.5 meters to 80 meters. Okay, that type of plants is called low head power plants. Okay, so the turbine used in such plants is nothing but Kaplan turbine and so low head power plants uses either Kaplan turbine or Francis turbine. Okay, this is also important. Just 2 marks also asks the give the classification of hydroelectrical power plants. Okay, the hydroelectrical power plants are mainly classified into three types according to the head of the water. Those are high head power plants, medium head power plants, low head power plants. Okay, whenever the head will be above 500 meters, that is called high head power plants and it uses the Pelton wheel. Medium head power plants is nothing but the head of the water ranges from the 80 to 500 meters. Okay, that is nothing but the medium head power plants and the turbine used in such plants is Francis. Low head power plants means whenever the head of the water ranges from 1.5 to 80 meters. That type of plant is called low head power plant and it uses either maybe Kaplan turbine and Francis turbine. See, I will only shows this is the construction of a Pelton turbine. See, this is the blades. Okay, whenever the water will flows through so this round shape is directly connected to the penstock. Okay, at that time whenever from the penstock the water will flows through these blades, at that time these blades will be rotated. This is Pelton wheel and this is a Francis turbine. Okay, and this is a Kaplan turbine. See, hydroelectrical power plant advantages. Okay, water is a renewable energy source. Okay, that means water is renewable energy source. There is no need to purchase it. Okay, that means it is available naturally and freely in the nature. Okay, maintenance and operation charges are very low. Okay, the maintenance and operation charges also very low, as well as the efficiency of the plant does not change its wage. Okay, so whenever that means the power plant age, that means the construction age of the power plant may be increases, the efficiency will not be decreases. Okay, so next one, in addition to the power generation, hydroelectrical power plants are also useful for flood control, irrigation process, fishery and recreation. See here for the for the purpose of the electrical power generation, here you can construct a reservoir and here and behind the reservoir you can construct a dam. Okay, so whenever you can construct the dam, at the time it is useful for the flood control. That means the total water will be stored on the behind the dam. Okay, at the time to decrease the flood, that means useful for flood control and irrigation purposes. Whenever the water will be required for the irrigation, at that time from the reservoirs you can supply the irrigation. And fishery means that means wherever you can growing up the fishes, those are nothing but the fisheries. Okay, so those are nothing but the advantages. Have a longer life as they are operate at atmospheric temperature. So if suppose you can construct a dam, so it can works for 100 to 125 years. Okay, water stored in the hydroelectrical power plants can also be used for the domestic water supply. Okay, so this reservoir water may be also used for domestic supply. This is also one advantage. Since hydroelectrical power plants run at low speeds 300 to 400 rpm, there is no requirement of specially alloyed steel construction materials or specialized mechanical maintenance. Okay, these hydroelectrical power plants are also run at speed of a 300 to 400 rpm. So at that time there is no special requirement for either a turbine or generator. Either there will be no special alloy steel construction materials or specialized mechanical maintenance will be not required. That is also one advantage. Coming to the disadvantages. Okay, the disadvantages of hydroelectrical power plant are the initial cost of the plant is very high. Okay, that means first of all you can construct the hydroelectrical power plant. The initial cost of the hydroelectrical power plant is very high. Okay, since they are located away from the load center, the cost of the transmission lines and the transmission losses will be more. Okay, whenever the electrical energy generated in the a hydroelectric power station, load centers has nothing but the substations. Okay, so from that substations are very far away from the hydroelectrical power station. So at that time the transmission lines, okay, transmission lines, that means the transmission lines you are using a very long distance. Whenever the distance from the load centers and the hydroelectrical power plant increases, at that time the transmission lines will be also cost also increases. So whenever the transmission lines length will be increases, the transmission losses will be also more. The transmission losses are also increases. Okay, during drought season the power production may be reduced or even stopped due to insufficient water in the reservoir. Okay, so already I said that previously, whenever in the summer season, drought season is nothing but and in Telugu I will say that drought is nothing but karu. Okay, so whenever the drought season will be occurred, at that time the power production may be reduced. Okay, so that means whenever there will be no water, how you can get the electrical energy from the water? At that time the power production may be the production of power may be reduced or even stopped. Okay, in some cases there will be no water, insufficient of water. At that time maybe stopped, even stopped due to insufficient of water in the reservoir. Okay, so water in the reservoir is lost by evaporation. Okay, so see, in summer seasons there will be a lot amount of temperature. Okay, because of that high temperatures the water in the reservoir may be evaporated. Okay, these are the advantages and disadvantages of a hydroelectrical power plant. Okay, so this is the first of all you will explain the working principle. Okay, from the the potential energy of the water is given to the turbine. Okay, whenever you have given the water, highly forced water to the turbine blades, at that time the turbine blades will be rotated. Okay, this turbine is coupled to the generator shaft. Okay, whenever this turbine will be rotated at the time it gives the mechanical energy. Whenever you have given mechanical energy to the generator through a turbine shaft, at that time it will produces the electrical energy. Okay, so this is about the hydroelectrical power plant layout working. Okay, so and the main parts of a hydroelectrical power plant. Okay, and these are the types of hydroelectrical power plants. Okay, so and this one is just I will show the Pelton wheel, Francis turbine and Kaplan turbine and advantages and disadvantages. This is about the hydroelectrical power plant. Okay, in next class I will continue on nuclear power plants. Okay.